Hello everyone, welcome back to my channel. Hope you all are doing good. Now we are going to understand how simple linear regression works in a practical way with a real-time example. And let us start without delay with our topic for today. Let us understand how this linear regression or simple linear regression, we have multiple linear regression, multilinear regression. So how the simple linear regression works in a practical way, or how the model fits and getting trained and getting predicted. We'll understand all the steps. And as this is the first example or the first practical one, so I have taken one of a very simple and generic seaborne data set. We will understand that, and it is going to be easier for you to grasp it. That's why I have taken car crash dataset. So what is the first point, guys? We need to load the dataset. For that, I am just taking sns.load dataset. Then we have before that we have imported all our libraries. We have imported matplotlib, pandas, numpy, and seaborn. So we have done that. We have we got our data. So what are the data it's containing? It's containing total, then speedy, alcohol, not distracted, no previous, insurance premium, insurance losses, abbreviation of the country. So what is the total, guys? So this total means total number of or the total percentage of car crash it happened, right? Then we have speeding. What is the speeding? At what speed? Like, or how many percentage of people are driving very speed? So these all are percentages. Okay. Then we have alcohol. How many percentage of people who are driving by consuming alcohol? Then who are the people who are not distracted? What is the do they have any previous history of car crash? This is a percentage of people. Then insurance premium. This is the insurance premium they have paid till date. Then loss. How many loss? What is the percentage or what is the amount of loss they have? These are the abbreviations. These are countries. CA means California, AR means Arizona, then like that. So once you like, what is the first point, guys? We understood the nature of the data. What we have to understand here is what is the target value. So we know, okay, these all are your columns, right? And we have total speeding, alcohol, what is the next step? We need to determine which one are the independent and which one is the dependent. So according to this data set, what could be our dependent variable, guys? See, all these factors like speeding, alcohol, not distracted, then premium and all, what exactly it helps? It helps to know the analysis of car crash, right? The analysis of car crash, whether it happened, like how much it happened for a particular person. So what could be our dependent variable here? Total should be our dependent variable here, because this total is your number of car crash happened for each and every person. And how the car crash happened, this is the analysis for that, right? So we are understanding the tail of it. Just I have taken the tail, then we are understanding the data dot shape. So we have 51 rows and 8 columns. Then we are understanding the describe part. So what is the describe part, guys? Describe is always going to give you the statistical or all the kind of statistics, like it is going to tell count of that, mean, standard deviation, then quartiles, quantiles, then for all numerical values, right? We have one more method to completely show all the values, but all these describe will be there for numerical values because that is a descriptive statistics, right? Then we have data.info. So in data.info, what we are observing that we have any null values or not, what is the data types present in this data set. So you can see all the data types are float here. However, one object, so that is nothing but your category. And do we have any null values, guys? This is one more important factor. By observing the data set, you should be able to understand whether you have null values present or not. So we don't have any null values present, right? We have 51 entries and each column has 51 entries. That means it is not containing any null values, or it does not have any empty space in that particular column. Again, we observe that we do not have any null values, but it is always a good practice to take the sum of it by using the null value or NA value. NN is NaN or is null. So these are the two methods by which we can understand whether we have any null values or not. And if we get a sum, you can see all zeros. So zeros means you don't have any null values. Then what is the next step? We are going to understand how many unique values are present in that particular data set. Then we are understanding whether we have any repetitive unique values or not by using the length function. You can see length of this unique is giving me the exact unique values present. So that means each and every data point is having a unique category. It's not repetitive, right? That means we understood that it has a 51 unique values of abbreviations. Then these are nothing but columns which I am taking. Then we have. Then I am plotting all the. I'm plotting all the box, like I'm just creating a subplot for all the columns, and this is what I am just dropping the column abbreviation because that's the category, and we cannot draw category in this in box plot. So you can see that I'm seeing the box plot presented for total, speeding, alcohol not destructed, no previous, then insurance premium, then losses. We do not have abbreviation. And do we find any outliers here? We do have, right? We are able to see that alcohol is having few circle points present. That means these are your outliers, right? However, we need to understand what is the difference of the highest whisker towards the outlier. So if you see the highest whisker, this point is somewhere around 7.8 or like that. However, the highest outliers is there at 10. So do we have much difference between them? We do not have. But however, it is always better to determine the outliers, and I have already explained to you there are so many methods, right? This is one of the method by using box plot, by using the pictorial form. Then we have G-score, MAD, mean absolute deviation, right? All those methods again you can apply and you can calculate. Then we conclude from the top that these are not outliers, and it is always better to understand, okay, do we have to go ahead or do we need to stop there and analyze more? And according to me, for this example, we need to go ahead with the further studies or with the further analysis. Okay. Then I am because as I am seeing that we have few outdated points or the outlier points, I thought of creating a scatter plot by taking X alcohol and Y total, right? Then I am getting the data point like this. These are the 3 data points it is shown. Then I am understanding the trend. Now is the point comes into picture. Whenever you are talking about regression, you have to understand the regression line, right? And to know the trend of the data, we have a plot called reg plot. And that's a SNS plot, and it is a very variable plot. So you can see that I have what I'm trying to do. I'm trying to create a regression line or all I am seeing here is the best fit line, right? Because that is nothing but you can understand the dependency factor between both variables, right? Between x and y, right? So what is your x here? Alcohol. And what is your y here? Or this is total is your dependent, x is your independent, or alcohol is your independent. So to understand the trend, you can see that these values which are present beside, these dots, and you can see few values are going towards on, or like you can see the regression line, right? Then I am creating a regression line for speeding and total. So this is a best fit line we are getting, but however you can see the data points are very scattered because we have not trained our model, right? Once we will start train our model, it will create a common regression line. Like it is not, however, it will understand each and every data point in this way. However, it is going to create one common regression line, and all these points, blue points which are seeing, which are really in scattered manner and the variance is more, it will come near to those data or those regression line. And this is the regression line for not distracted and total. And this is the best fit line or the regression line for no previous and total, right? So we understood this. Now we will see whether those values are actual outliers or not. Let us see. So how to understand that this is a Boolean indexing. I have already explained it. If you're forgetting, then please go ahead and understand that by going through those videos. Then we have like how we are calculating. We are understanding as from the plot we are seeing that the values might be beyond 8, right? So I have taken I want to know whether how many points are coming beyond 8. So I am just taking greater than 8. And it is giving me 3 rows. And I do not have to take any action because those values are very near to it, right? Now, I'm just, taking the, or I'm just understanding the p-value of it, or I'm just trying to get the data from it, and this is the data pen. Now, we will see the heat map. What is the next step, guys? We understood the trend, we performed the EDA part. Now, what is the part? We have to understand the correlation between them, which is nothing but your feature engineering, right? So, here in heat map, we are dropping, this is the complete data, right? And we are dropping the abbreviation column. What is the formula for correlation, guys? We have dot core. So once we will put these formulas, we are getting the heat map. This is the heat map. And how to read the heat map, I have already explained you in our previous videos. Just understand that any values which are very less, those are very loosely fit towards the dependent variable. So this is a dependent variable. So if you see that 0.61, right, 0.61, you can see 0.61 is having a moderate relation, or it's a good relation. Then this is your alcohol, 0.85, good relation. Then alcohol to speeding, 0.67. Then alcohol to not distracted, 0.73, 0.59, 0.83. So all these are a better, or it's a better dependency or better correlation. That means these are dependent to each other. Like these all values are dependent to each other. However, when it is coming to the insurance premium and insurance losses, you can see the values are very less. It's not at all dependent. That means what is the next step? We have to drop the non-dependent or the non-correlated columns always as a part of feature engineering, right? That's the step we are going to do in the next one. So we are dropping the columns here, and here I am adding the abbreviation also, because now is the step when we are going to start with our machine learning or to train the model. So I am dropping the columns. Now after dropping the column, this is my head, which has a total, speedy, alcohol, not distracted, and no previous. Now the point will come where we are going to train our model, and these steps are new for you because we have not studied or we have not understood till now. And my question is, do we have to transform this data? According to me, it's not needed, because if we see the data points, those are not so far away from each other, right? Suppose one example I will give you. If you have one more column which will be presenting here with thousands, in terms of thousands, in that case, these data points needs to be scaled up, maybe in a one scale, right? However, this is not needed because you can see all the values are ranged between 25 to 7 or 6. I believe it starts with 3 or 4, then it ended with 21, right? Now we will understand how we will perform the model, or how we will train the model. So we have sklearn as a library, sklearn is scikit-learn, and we have model selection as a module in that. So you just need to use sklearn.model selection import train test split. Import train test split. So what exactly train test split is doing? When we are talking about train and test, that means we are saying that, okay, we have training data, we have testing data. And when as per the term train test split, we are splitting the data. It is always a better practice to give more amount of training data, however the less amount of testing data, because we are just verifying the data whether it's correct or not, or the model is predicted correctly or not. So training data should be more and testing data should be more. And how we will define that in the next step? We need to pass those variables, right? Because these are the variables which will contain your individual data points, right? So we are defining our x train, x test, y train, y test, because we have two variables. And for two variables, if we'll split it, how many it is going to come? 4. So we got 4 variables here, and we are using this method, train test split method. What is the thing we are doing here? We are passing the independent variable, then dependent variable. This is your independent variable. This is your independent variable without total, because total is not containing, total is containing a dependent variable. And if we'll pass dependent variable for your training, what is going to happen? It's going to overfit the model. This is your dependent variable, because as we are splitting the data, we need to split in a correct way. So we have passed independent variable, dependent variable. We are passing random state. Random state is a method, or is a point where we are just saying that, or it's a kind of seed. I have already explained to seed in our random video, or NumPy random. Understand that by going through that video if you are not able to recall. We understood seed, right? And when we are telling seed, means what? We are telling the model that you need to take this particular combination and you need to apply that combination every time when we are training the model. It should not be separate data. It should be that particular amount of data which you are considering in the first step. So that is a random state. And it can be of any value. It is not 42. 42 is a common value which you are taking. Then you have to define test size. You can define train size, but it is not needed. If you want to define train size, the value here, just should be 0.9. If you are defining train size, so it's going to be train underscore size. However, I am defining test size for the better understanding. That means we are saying that test size should be 10%, train size of data should be 90%, right? Then I am running this model. So now if you see that, okay, train test, I need to run this, then after that I need to run this. So now in this step, what is happening? I have my train data, I have my test data for both dependent and independent variable. If you want to know, let me just show it. If you want to know what is the data present, you can just do like this, xtrain.head, right? Then you can just go like, and if you want to know the length or the shape of it, you can just click like that. So you can see that train data, it is taken 45, and you want to know test data, x test dot shape 6. So train data is 45, test data is 6. Then y test y train dot shape 45, y test dot shape 6. Now I will show you what is going to be the problem in future, like when we are going to train the model. So now we have got our data correctly. Now we are going to apply the linear regression. This is a simple linear regression, and this is the method. This is the method, linear regression we are going to import, and this is the module. Linear underscore model is a module of sklearn. From there we are importing linear regression. And we know that Python is based on all objects and classes. It's based on class and object methods. We are going to create an object of linear regression. This is how we are creating object. Now, what is the next step? We have to fit. What we have to do? We have to fit our model. So, what we are doing for fitting? We need to fit xtrain and ytrain. We are fitting training data, right? Because we need to take train data and we need to train the model. So, if we do that, and we will open the parameters section, you can see these are the parameters which got applied. And again, it's a black box. For that reason, I have explained you in previous videos how it is happening internally. So now what is the next step? Now we have trained our model. We need to predict, and we need to predict on what? We need to predict on our test data, right? So this is how your predicted value looks like, right? This is a predicted value. And if you want to know the difference between test and prediction, right? Prediction and test data, right? This is your variance. This is your variance, or this is the difference, or this is the error part, right? Just imagine all these things. You will be able to, get it there. Then I want to know the test score, like what is the score I'm getting. I'm getting 90% of accuracy, which is good, right? Then we can understand the different factors or mean square error and all these things. And we studied about R square score, right? So this is your metrics. This is your metrics because these are the methods by which we can compare different models. Okay. So how we are getting these are R2 square or R square. We have sklearn, we have metrics as a module, and we need to import it. R2 underscore score. This is what. And after importing, what we need to do, guys? We are getting the difference between actual and predicted. So what is your actual value? Y test is your actual value, and we need to pass the predicted value, and it's the same thing we are doing. We are getting same 90% accuracy. Then what is the next step? We are calculating mean square error. Mean absolute error. So mean absolute error is again present in metrics module only. So we are just importing mean underscore absolute underscore error. Okay, and again we are passing Actual and predicted. We need to pass it. We are getting 68% error. That means what exactly is the meaning? That means 68% of data is getting defined by another 30 or 22. Yeah, another 20, no 22, 32% of independent variables is getting defined the 68% of output. Then we have mean square error. Again, it's coming under metrics. Then you can see that we are getting so much, right? I mean, this is the error percentage. Then we have root mean square error. So for root mean square error, we need to, just need to parse y underscore test. You can see it's coming 1.05. So this is how we are defining our metrics, and this is how we are understanding or training our model and predicting. So after this, what is the next step, guys? Again, we are going to save this and in terms of some file. Then after that, next time, whenever any new data is going to come, it's just going to predict. That's it. Okay, so we understood on how we are performing on the data, right? Now we will understand further topics in our upcoming videos. Till that time, see you. Thank you. Well, that is all for now. We will cover further topics in our upcoming videos. Till the next time, see you. Please start subscribing, like, share your comments, share your feedback, share this channel link to all your friends and near ones. And till the next time, see you. Bye. Take care. Thank you.